we talked about how a log function is actually just the inverse of an exponential function. So if you remember those exponential functions from chapter 7 just a few days ago, those were the ones that were either decreasing like that or increasing like that. Those guys, they were the ones that had the asymptote right there at y equals 0. Sometimes that translated up or down, right, depending on transformations. So today we're going to be graphing the log functions, which is the inverse of these. And remember, inverse just means that the x and y values switch. Okay? So because the x and y values switch, okay, that means the asymptote will also switch. So instead of having a vertical asymptote now, we are going to have, or sorry, what did I just say? I said vertical, sorry. Instead of having a horizontal asymptote, we are now going to see a vertical asymptote because everything's just kind of swapping, okay? And remember, with these guys here, there was often no x-intercept, right? Because you would approach the x-axis but not touch. So this time, that switches too. There will now be no y-intercept, okay? And just like the opposite of exponential functions, there was always a y-intercept before, right? Right here. Now there will always be an x-intercept. So like everything we knew is just swapped, okay? So here we go. We're going to sketch the graph of y equals log base 4 of x plus 4 minus 5. Okay. What we're going to do is we're going to sketch the original graph first. So what I mean by sketching the original is I want to sketch this log function with none of the transformations. So the transformations are these guys here. So we can see in this equation, I've given you an h and a k. Remember, a, b, h, and k are the transformations. So I've given you an h and a k. But first, we're going to draw it without any transformations. Then we're going to create mapping notation, and then we're going to sketch the transformed function. Remember mapping notation from chapter 1? Okay, we're going to do that. We're going to determine the x-intercept and y-intercept if one exists. Then we're going to state the domain, the range, and the asymptote. So we've got a lot to do. We have to sketch two graphs, original and the transformed. So that's why I left you so much space, as you can see on your notes, right? This whole question is going to pretty much take up the whole page. So I'm going to start with the original. That's what it asks us to do, is to sketch the original. So if I am sketching the original, that means I am sketching just that. So you'll notice I took this guy here and I just removed the h and k. So that's like my base log function. There's no h, no k anymore. Now, remember yesterday, we talked about how we can change that log form to exponential form. The way we do that, the base of the log becomes the base of the big power. The answer, which is y, becomes your exponent. And then the argument is the answer of the exponential form. So that's what we did. Yes, we converted between the two. So we're graphing these guys. I'm going to create a table of values, as I do with graphing usually. So there's my table of values. I always put x on the left, y on the right. Now, careful, slow down here. Usually what we do, don't write this down, usually on the left we do something like that, right? Usually. But we have to remember that this is actually an inverse function. The graph of a log is an inverse function. When we are graphing an inverse function, everything swaps. Everything we do is backwards. So the -2, -1, 0, 1, and 2 will be my y's. Everything is opposite of what we're used to. Okay. So then I have to take these values here, and where I see a y in that original, or sorry, in that exponential form, I replace y with those 5 values there to find my x. So what I mean by that is over here, this first guy, I will see 4 to the power of -2. That equals x. Okay, and that's what I'm looking for. I'm in the x column. So 4 to the negative 2 is equal to 1 over 16, right? Negative exponents, you just send it down. So I actually have 1 over 4 squared. Do it again. 4 to the power of negative 1 now will equal my x. So that is equal to 1 over 4. All right. If I go 4 to the power of 0, that will equal my x in this case, which is 1. 4 to the power of 1 is just 4. And then 4 squared is 16. Okay, so there's my points. Okay, so I didn't put in a grid for you. My apologies. But we're just going to do a rough sketch anyway. Okay, so there's my grid. I'm going to graph this guy. Okay, on my x-axis, I see on my x-axis that I have to go all the way up to 16. So you can choose what you want to do, jump by 1 16 times, or jump by 2 maybe, or jump by 4, it's up to you. I'm going to jump by 2, so 2, 4, 6, 8, 10, 12, 14, 16, but you can jump by whatever you want. And if you jump by something other than 1, you got to let me know. Like you got to write a 2 in, so I know your scale is 2. And another thing you could have done here, you have no negative x values. You could have just drawn just it like that, whatever. You draw your graph how you see fit. Now for y, pretty easy. I got to go up to 2 and down to negative 2. All right. Asymptote. Usually we'd have an asymptote horizontally, right? But I've already discussed how this is an inverse function. So our asymptote this time is vertical, and that goes through x is 0. So instead of an asymptote at y equals 0, it's at x equals 0, and it's vertical. Okay, let's plot these points. They're going to be a little bit cramped, but the first one is this point here. You can convert 1 over 16 to a decimal. Okay, that's what? Can someone help me? It's like 0. Not even 0.01. 1 divided by 16? What is it? 0.06. Like we'll barely be able to graph that, right? And then negative 2. So I go down to negative 2, and if I only want to go 0.06 in, I'm essentially right beside the asymptote, like as close as I can get. Pretty hard to graph that. All right, the next one is 0.25 and negative 1. Okay, so 0.25 on x and negative 1. I'm just a little bit further away from the asymptote. Next one is my intercept. Okay, so when x is 1, y is 0. So because I jumped by 2, I got to go halfway there. And so you can see I'm just slowly getting away from my asymptote. Next point is at 4, 1. So when x is 4, y is 1. And then finally 16, 2. So 16 was way out there. And now you can see you're trending. There's your curve. You approach the asymptote, but don't touch it. And that's the inverse function. Okay. It asked me to state a few things. Okay. So it asked me to state the x-intercept, which we already found. We graphed it. It was in our table of values. Okay. There is no y-intercept here. We didn't cross y. My domain it asked me for. This is not a freebie anymore. Remember with exponential functions, x was the freebie? Not anymore, because you can see we're only on the right side. So my domain is x is greater than 0. So if you remember exponential functions, it was always y was greater than 0. Everything has swapped. And then my range, that's now the freebie, because I am way above and I'm always way below forever and ever. So those domain and range kind of swap. Okay. And then it also asked me to state the asymptote. The asymptote was at x equals 0. Okay, that's the original. Now it wants us to use mapping notation. The instructions say create mapping notation. We're going to bring back the h and the k, and we're going to figure out what our new points would be. Okay, so I'm just going to kind of cut my page here because now I'm working on the transformed guy. So I did the original. So now I'm back to actually graphing the transformed log function. And to do that, I'm just going to do mapping notation. I'm not going to create a table of values. I've already done all that work. So mapping notation. Remember with mapping notation, we took our original XY and we drew an arrow and we asked ourselves, what would our new XY be? And we put the transformations in there. So this value right here, your H affects your X. You know that all of your X values will be shifted left 4. So remember, you have to switch that symbol. And then all of your Y values are affected by this K. And that symbol won't change. So all of your Y values, minus K, sorry, minus 5. All of your Y values will go down 5. So we're going to use our original points that we already found in our table of values and apply this mapping notation. Now, this is where I'm going to allow you to be a little bit lazy. If we look at our points, it would be gross to apply mapping notation to those because of the decimals, right? So I will allow you to only apply mapping notation to the 3 easier ones, because we know if we can find 3 points, we know we just follow the trend. It's always going to be a curve. So you can just extend the curve. So we're just going to do those 3 easy ones. We're going to avoid the decimals. All right, so my first easy point that I found in my table of values was that intercept, which was y0. Oh my God, y0, 1, 0. So when I apply my transformation, 1 minus 4 will become -3, and 0 minus 5 will become -5. My next easy point was 4, 1. Apply the shift, it will be 0 minus 4. And finally, my last one was 16, 2. So this will become 12, -3. So very rough sketch. I am plotting just those 3 points. So if I take a look here, my x-axis, I have negatives and positives. I got to go all the way up to 12. Because my values are 3, 0, and 12, I'm going to jump by 3, okay? Because I know that will work easily. So 3, 6, 9, 12. And then over here, I just got to go to -3. You can fill it in extra values if you want. Your graph is your call. And then for my y's, I'm only negative. -1, 2, 3, 4, 5 is the lowest I have to go. Jumping by 1. All righty. Before we plot in our points, we're going to plot in our asymptote. We will always still have an asymptote. Now, think back to chapter 7. Your asymptote was always horizontal, and it either went up or down, depending on what value. Which value told you? It was your K. Your K told you if K was -3, your asymptote was down at -3. Okay, so everything has swapped. So what's going to determine our asymptote now? H. Whatever happens to X. So my H value is that +4 in the bracket, right? But -4. So now our asymptote is going to be at -4. So, well, I jumped by 3s. That kind of shot me in the foot, but that's okay. I'll just go like that. x is equal to -4 is my new asymptote. So whatever your h is. Okay. Now let's plot our 3 points. So the first one is -3, -5. I'm down there. 0, -4. That's my y-intercept. I have a y-intercept now. We usually don't, but because we've shifted over, I do. And finally, 12, -3, 12 on x, -3 on y. So we kind of just extend our curve. Oop, that wasn't good. I didn't connect my dots very well there. Okay. And down here, make sure that that end of your arrow at the bottom sharply curves down. You cannot cross over that asymptote. Okay. You can approach, but not cross over. And that would be the graph of the shift or the transformed function. So again, it asked us for a few things. Let's state our few things. Okay. It asked us, you guys, in the instructions to state the x-intercept. The way we drew our graph, we do not have an x-intercept. We cannot see where it crossed. So we have to find it. Luckily for us, we are very familiar of how to find x-intercepts. You just sub in y with 0 in the equation. Well, what was our equation? It was the log guy. This is what we're graphing right now, right? So to find my x-intercept, I have to plug it into that. Okay, so I plugged y in with 0, and we're going to solve this. And we did this yesterday. But yesterday, this guy would have just already been over on the left. So like yesterday, I gave you stuff like this. So just send that 5 back over. And now that's the normal log form that you're used to. Okay. If we convert this to exponential form, the base of my log is the base of my power. The answer, which is 5, is my exponent. And that should equal my argument, which is the x plus 4. All right. So I'm just going to keep solving here. 4 to the power of 5 is 1024. So that's my new left side. And then just minus 4, minus 4. So my x-intercept would be on the x-axis at 1020. So this curve right here would slowly trend upwards, very slowly. And by the time it met the x-axis, it would be down at 1020, pretty far down. So that's our x-intercept. It asked me also to state my y-intercept. We already found that. My y-intercept was 0, -4. We plotted it. And then it asks me now for domain and range. Your domain will change because your asymptote shifted. All of your x values are now greater than -4 to the right of -4. And then your range is your freebie. Okie doke. So that took us a while. But now the good news is we don't have to graph anymore for today's lesson. All right. Let's get into this. All we're going to do here is just state the transformations. We have done this quite a bit. I want you to tell me what's going on in this transformed log function, but then also we're just going to practice mapping notation again, getting our mapping notation correct. But I'm not asking you to graph it. You have to identify what would the asymptote be, what's the domain, what's the range, what's the y-intercept, x-intercept for all of this stuff, but we don't have to graph it. Okay, so first of all, transformations. I just work from left to right. I see a -3 and I'm going to write down what that does. That -3 is your A value. That means we have a vertical reflection. That's the negative. Okay, the negative is the vertical reflection and also a vertical stretch by a factor of 3. We don't flip that guy. 3 is 3. All right, that takes care of that. Okay, that little teeny tiny 4, that's not a transformation. That's the base of the log. Leave him be. But then the big 4 on the outside of the bracket, that's your b value. B is always outside of the bracket of x. So that means we have a horizontal stretch by a factor of 1 over 4. You got to flip that b. Okay, then in the bracket, I see that other 4, and you can write the negative now, like it's a positive 4 in the bracket. You can choose to write the negative now. Doesn't matter to me as long as you state left in your sentence. So I know you know what direction it goes, okay? So horizontal, translation, or shift for left. And finally, the 2 is a vertical translation to up. Okay, so I've stated the transformations. Now we're going to state what the mapping notation would be. So my xy would become what? Okay, so my new x coordinate has been affected by a horizontal stretch by a factor of 1/4. So all of my x values are multiplied by a quarter. But then also all of my x values are shifted left 4. And then your y values are affected by a vertical stretch of 3. So all of your y values are being multiplied by 3. And then after that, they're all being shifted +2 or 2 up. Okay, so we're done the transformations. We're done the mapping notation. Now we are going to identify the asymptote. That's the next thing the question asked for. The asymptote is determined by your horizontal shift. So your h value, okay, which is +4. But what? Oh, sorry. Yeah, right here should be a -3. Thank you. It was a vertical reflection too. Thank you. Thank you. So your asymptote is your h value. So because we shifted 4 left from normal, that means your asymptote would be at -4. Good? Alrighty. Then I asked for domain. Your domain is dictated again by your asymptote. Your asymptote is like your wall. So all of my x values are greater than -4. You have to be careful. If there would have been a horizontal reflection, right? If there would have been a horizontal reflection, whatever was right would have come left. So your domain would have been less than -4 because we would have been on the left. Do we have a horizontal reflection here? No, it's on the right. So all of my x values are greater than -4. So just like this, it would have looked like that. Okay. If I would have had a horizontal reflection, though, that's what I mean. It would have been on the left. So your domain would have been your values are less than -4. So you have to watch if there's a horizontal reflection when you state your domain. All right, your range is the freebie. Okay, what else did I ask you for? Y-intercept. Okay, so to figure out your y-intercept, you sub x in with 0 in your equation. Okay, so we got some work to do. My equation was y equals -3 log base 4 of x plus 4, so 0 plus 4 plus 2. And we have to simplify this. So I have -3 times log base 4 of 4 plus 2. Okay. I'm missing a 4, aren't I? There's a 4 right here, right? Sorry. Oh, I'm not at my best today. There's a 4 on the outside. Okay. So then that should look like that, right? Because you have the original 4 and then 0 plus 4. My bad. So you actually have -3 log base 4 of 16 plus 2. Okay. You tell me, what's the answer to that? If I ask you for log base 4 of 16, what's the answer? 4 to the power of what gives you 16? 2. So this is actually -3 times 2 plus 2 to solve the log. And the -6 plus 2 is -4. So your y-intercept when x is 0, y is -4. Okay. This is the last thing we have to find now. It's my x-intercept, which is when y is 0. So now we have 0 equals -3 log base 4 with a big 4, open bracket, x plus 4 plus 2. I think I did that right this time. Okie doke. What the heck do? We send this -2 or this 2 over, and it will become -2, just like we did in the question above. I am trying to get this x out and all by itself. So I'm going to try to get rid of anything I possibly can. So now I'm going to divide off that -3. So on the left, I have 2 over 3. The positives cancel. Log base 4, big 4, x plus 4. Lots of 4s. All right. So I actually have 2 over 3 log base 4 of 4x plus 16, right? Like this is the argument. Whatever comes after your little teeny tiny 4, that's the argument. So clean up your argument if you can. Distribute, clean it up, no brackets. So there we are. So now, if I put that in exponential form to solve for x, the base of the log is the base of your power. The answer is your exponent, and that should equal the argument. Okie doke. So now you solve, and you have to solve for x. So I am going to -16 from both sides, but before I can -16 on the left, I have to figure out what does this equal? Like what is 4 to the power of 2 over 3? This is where you can use your calculator, because this means the cube root of 4 squared. Well, 4 doesn't have a cube root that we can see, right? We have to find the decimal then. We have no other option. So on your calculator, you're going to take what's the cube root of 4. You're going to get a decimal, leave the decimal, but then square the decimal after. And when you do that, you should get 2.519, etc. But remember, you still have to -16 from that. I haven't minus the 16 yet. So I have 4.519, blah, 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 blah. You can even keep that in your calculator and -16 off of that. And I don't have that number written down on my sheet. I divided by 4 right away. So 2.519-ish minus 16, you should get like -13.481 equals 4x. And now you divide off that 4 and you should get like -3.4. Okay. And I think we're done. We have answered everything they asked. Okay. I know this is a long lesson today. I know. We're going to speed it up here with this guy. This one's really quick, actually. So for this one, I already give you the graph. All I am asking you to do is tell me what is the equation of the transformed function from this guy. So that's the original. Okay, so the red guy on top is your original. I want to know what is the equation of the blue guy. So we have to figure out what transformations happened. Okay. So we are going to, it is hard to determine if a curve has been stretched. That's hard to do, okay? So when I ask you for the transformed equation of a log function, all you're going to ask yourself, is there an H? Is there a K? Are there shifts? That's what we'll figure out, because stretches are hard to figure out on a curve. So we're going to avoid that. To figure out if there's an H or a horizontal shift, look at asymptote, right? Because your asymptote is dictated by your H. So my original asymptote, I can tell, or I know, we've discussed this, I know the original asymptote is always a vertical guy at x equals 0. And we can tell it's, that red line is approaching it, but not crossing it. Where is my new asymptote? You can tell it's right here. What is the blue guy slowly approaching but not crossing? It's that line. And that is at x equals 2. Boom, we just found our H. Okay, everything shifted to the right 2. Okay, to figure out if we obviously can tell everything shifted down. So the way I figure out what we shifted is I pick a point on the red one, and I like to pick an exact point, obviously. That exact point is 0, right, not 0, 1, 1, 0. Oh my goodness, 1, 0. And then I picked the corresponding point on the blue guy. So I picked the butt of the curve and the butt of the curve on both. And this guy right here is at 3, -5. So I can tell I have that shift of +2 that we've already discovered. We knew that already. So that just confirmed that. And now I can see my y values shifted down 5 from that corresponding point. So if I were to write this equation, I would have y equals log base 3, but now I have a bracket on my x. I know my asymptote shifted to right, so I'm going to write -2 because opposite symbol, and then all of my y values shifted down 5. Done. So only worry about your H and K. Alrighty. And last but not least, we've got a word problem. Word problems are not that hard because I will always just give you the equation and you just got to plug in properly. Okay? In a study, doctors found that in young people, the arterial blood pressure, which we will define by P, in milliliters of mercury, which we will define by mmHg, is related to the volume, V, in microliters of the radial artery by the log function, blah, blah, blah. So this log function describes your blood pressure based on the volume of blood you have. Okay? I want you to determine the volume. So how much blood would a person have if the pressure is 120? So I have given you P or pressure, and I am asking you to find V volume. So in your equation, you keep V as V. You rewrite the rest. What's my base of my log here? 10, because it's not there. And then in the place of P, I write 120. And we just clean up. All right. So I actually have volume equals 0.23 plus 0.35 times the log base 10 of 63.9 if I subtract those two. Okay, here's where we can use our calculators. Okay, I want to figure out the answer to that. So that's asking you 10 to the power of what gives you 63.9? We can't figure that out in our heads. 10 to the power of what is 63.9? I have no idea. So you take your calculator out. Your calculators are already in base 10. Okay? So you just find your log button on your calculator, and it depends you either type in 63.9 first and then press log. That's how my calculator works. Or you just type in log, it'll pop up a bracket, and then you type in 63.9. And you should get 1.81. It's 1.8055, whatever. So that's the answer to this, 1.8055. And you can keep that decimal in your calculator because you know that is now multiplied to 0.35. So keep that decimal in. When I multiply that by 0.35, I get 0.6319, blah, blah, blah. And then all I do in the end is add the 0.23, and you should get 0.86. And volume is measured in microliters. So your calculator does your work for you when it's a base 10 like that. Okay, and now let's do one the other way. This time I am giving you what the volume is. So your left side V is replaced with 0.4. We recopy the rest. This time I will still have that P in the bracket. I have to isolate the P. So if I am isolating P, I am going to start by getting rid of everything I possibly can. So first I'm going to subtract 0.23. I get 0.17. I still have that 0.5 times to this log. So to keep isolating P even more, I'm going to divide off that 0.35. That's out front. And my decimal is now 0.49 on the left. And finally, my log is isolated. So, calculator again. What this is actually asking, it is actually asking you, or telling you 10, base 10, to the power of your answer. So 10 to the power of 0.49 is equal to your argument. So that's actually what I've got now. 10 to the power of your answer, or is your exponent, equals your argument. So on your calculator, you will figure out what is 10 to the power of 0.49. So you have to find your power button. 10 to the power of 0.49, you should get 3.09. And if you can't get that, I can help you. And then you just add your 56.1 and you get 59.2-ish equals P. And the unit for pressure is millimeters of mercury. All righty. Okay. That was long. Thank you for your attention, Abby. You were just a champ today. Everyone on the video is going to get to that part. Okay, required questions. Okay, on page 389, this is not due until, I don't know, Wednesday? Holy smokes, I should just make you do all of it. No! Okay, holy. Page 389, number 1, yes, you're going to do. Number 3, yes, you're going to do. Okay, for 5, I gave you A, B, D. You can just do D. That's the hardest one. Number 6, you're going to do just 6AC. Number 8, you can skip number 8 completely. Number 9, you can skip completely, and then you will do 12B because that's the word problem. Okay, and that's due Wednesday.